So coterminal angles are two angles that have the same terminal side. So how to find coterminal angles is one of the last things I want to talk about out of the the current section we were on. So here's your initial side over to the right, pointing to the right, and then I just chose 135 degrees. An angle that is coterminal to that would be one that we would draw like this, starting here and then wrapping around like that. That would be an angle that would be coterminal because it would stop right here at the 135 degrees. Okay? Now, how many degrees is that? Well, 135 degrees, what did we do? We went to 135. Okay? Going right here is 135 degrees. And then we went around another 360. So how far is that? That's 135 plus another 360. Alright, it's adding another 360 degrees because it's continuing to go counterclockwise, which means we're getting more and more positive, so we're going to add that full revolution of about 360 degrees, so that is 495 degrees. So that is also 495. Okay, so I'm going to put them in the same spot because they are ending at the same spot. But the color coordinating hopefully makes it obvious that, well, that's a different angle. It's more of a rotation, but it ends up in the same spot. You can find another coterminal angle by subtracting. Okay? I mean, you could find another coterminal angle other than the one I'm finding right now if we added another 360. Alright, but in the problems of the book, ask for one positive and one negative, so it behooves you to add and subtract. But you could add 720, you could add 2 rotations, you could add 1080, that's 3 rotations, you could add any number of rotations, and you would come up with a coterminal angle. So if we do 135 minus 360, that is, I should have done this before, I'm tired, my mental arithmetic is not at its best, that should be, well heck, negative 225. If I looked at the picture actually, a little easier. So negative 225. So that is this angle maybe right here. That's negative 225. And notice why is it negative? I mean, how could you tell by looking at it that it was negative? Well, I went clockwise. Clockwise is negative. Counterclockwise is positive. So there you go. That's how you find coterminal angles. Now what if it's given in radians? So just to make it clear, hopefully. Boom. All three of these angles are pointing the same way. Negative 225, 495, 135, but we get there in different ways, different rotations. So let me do another one here, but with radians. So let's do one that's not too bad. Let's say pi over 3, I should say. Pi over 3. Okay, so right here, this rotation. Okay, that's a little better. Alright, so if we rotate once more around, and boop, that's adding 360 degrees, but let's do it with radians. So 360 degrees is 2 pi radians. So what you do is you do pi over 3 plus 2 pi. Okay, so the reason why students tend to not like radians as much as degrees is because they're really fractioning. All right, so what you have to do is and fractioning is a word because I said so. What you have to do is you have to find common denominators. So it's pi over 3 plus 6 pi over 3. Wait, where'd that come from? Well, if I need common denominators, they both better be 3's. So I do 2 pi times 3 is 6 pi over 1 times 3, which is 3. So then this is 7 pi over 3. Okay? You should be taking notes here, guys, as always. 7 pi over 3. Because really right now what I want you to verify is that what you could do, and I'm okay with it, it's kind of chickening out a little bit, but you can convert to degrees, do the problem in degrees, and convert back, and that would work too. I wouldn't, take off points. I'd be a little disappointed because I want you to be able to work with fractions. But I'm okay with this kind of an end around. I understand, although I would prefer you to do what I just did. I think that's better. Okay? But if you did this in degrees, convert pi over 3, convert to degrees, you get 60 degrees. Plus 360 degrees, because that's 2 pi, you get 420 degrees. If you convert this guy here, well, actually the way I would want you to do it, let me not talk about it this way. How I would want you to do it, how you would have to do it. Okay, if your initial problem, by the way, and my general rule is, and it's not just unique to me, is that if a problem is in radians, your answer needs to be in radians. So let's say you cheated, quote unquote, and switched to degrees. I'm not going to freak out about it. You got 420 degrees. Okay, 420 degrees is equivalent to 7 pi over 3. 7 pi over 3 is what I want as my answer, and these are equivalent, but this isn't the right format. So what do? You got to convert back, and so if you convert back, you get times pi over 180. I'm using the mouse to write for some reason here. Let me do the thing. All right, do the pad. So if you multiply 420 over 180, this reduces to 7. Still have the pi over 3. So if you want to cheat, if you want to convert, which I didn't show, because 2 pi and 360 are the same, you get 420, you convert by multiplying by pi over 180, and you should get the same answer. That's okay. I'm a little disappointed, but there you go. So 7 pi over 3 is at the same spot. It is coterminal. All right. This is also 7 pi over 3. Difference between rotations or revolutions. I didn't finish my sentence. And, well, it's not even a sentence, is it? And degrees for radians. I'm just going to give you the conversion factor. So there they are. Here's the 4 conversion factors, and it seems like a lot, but they should all make sense. I mean, like, I don't really have these memorized or anything. It just, they make sense. All right, so once around is 2 pi radians, or actually let me use degrees first because you guys have a better understanding of that. So once around, one revolution, one rotation, whatever you want to call it, is 360 degrees. So these are the two fractions you use. All right, so you start with degrees and want to go to revolutions, you do 1 over 360. You basically just divide by 360. Multiply by 360 if it's the other way around. For radians, well, 2 pi radians is once around. Okay. So you divide by 2 pi radians, you can do 1 over 2 pi when you want to convert 2 revolutions and vice versa when you want to do vice versa. Reciprocal, you multiply by 2 pi if you want to convert from revolutions to radians. Sorry, I'm kind of going through that a little quickly. Probably something we can do together in class without that much trouble. I want to concentrate on this for the last 5 or so minutes or so of the video. All right, so here's the thing that I kind of want you to try to do your best to fill out as much of this as you can. So for instance, right, you should have done a lot of the work, and you might not be able to see too well, but here's all the angles other than the ones that are actually on the axes. So 30, 45, 60. Okay, notice those are the special right triangle numbers. 120, 135, 150, so on. Okay, what I want you to do is to note what all the radian measures are and put those in the boxes. Okay, that's what I kind of want you to try to do. That's step 1. All right, so I'll just start it off for you. So this is, you've already done a lot of these. This is 0 or 2 pi. Okay, so I guess I should probably, that one's kind of, you could put both here. Boom, 0, 2 pi. This is pi over 6, pi over 4. Okay, pi over 3. Pi over 2. So a lot of these you've already done. This is all, I don't know, I'll give you one more. This is 1, 2, 3, 4, 5, 6, 7. This is 7 pi over 6. Okay, let me fix that a little bit, but 7 pi over 6. That looks a mess, but Okay? 7 pi over 6. Alright, that's one thing. The other thing I want you to do, which may seem a little weird, is figure out what the ordered pairs. There are 1, 2, 3, 4, 8, 12, 16 spots on here. I want you to figure out as many of the coordinates of the ordered pairs as you can. Alright? This is the unit circle. So I'll just start one off. I'll do like the easy one because I'm a jerk. This is over 1. The unit is 1. This is the origin. Alright, you don't have to tell me the coordinates of that. This radius is 1. So this is the ordered pair over 1, up and down 0. So it is 1 comma 0. Okay? This one. Well, oops. This is a 30-degree angle. So actually, let me go ahead and I'll pause it and make the triangle I want to use. So I made a triangle kind of goes with this guy, and I made a triangle just for kind of as a random one, sort of, for that guy. Okay, so these are two special right triangles. These are special right triangles that you hopefully remember from algebra, from geometry. They are a 30, 60, 90. And so this is 30 in here. And a 45, 45, 90. Okay? Alright, so I've drawn these and I've labeled the angles. And the one side we know. We only know one side. We know the one side. But we know that since it's a unit circle, the hypotenuse is 1 because the hypotenuse is equivalent to the radius here. It's the radius is where I got the hypotenuse in both of these pictures. Alright, so the 30, 60, 90 is over here. The 45, 45, 90 right here. Let me draw it straight down. Okay. So that's kind of what I tried to emulate here. That's this guy. Okay. So let's find the other two sides, because guess what? That will tell us the coordinates. Alright. Over to the right, up this, this amount. That's over to the right, up this amount. Similar deal. Over to the left, up this amount. That'll tell you your x and your y. So we know our coordinates. How do we figure that out? Well, we can use trig. Or if you remember from geometry, you might just, remember. Alright. So we can do let's just think geometry. Okay, so go back. You might have to take your geometry notes out, go to the internet. You're on your computer, on the internet already. The hypotenuse of a 30, 60, 90 right triangle, you take that and you divide by 2 to get the short leg. So the short leg has got to be 1/2. Okay? What do you do with the short leg to get to the long leg? You multiply by square root of 3. So square root of 3 times 1/2, so square root of 3 over 2. So, make it a little smaller, because I'm going to clone them. So this is totally from geometry. Alright? Hypotenuse is 1, because it's a unit circle. We chop it in half to get the short leg. So that's the y value, isn't it? So let me go clone it. There we go. Okay, so it took a little too long when I did it the first time, so I just stopped and rewound it. Boom, here you go. Over root 3 over 2, up 1/2, so the coordinates must be root 3 over 2, 1/2. Here, if you divide by root 2, you get 1 over root 2 and 1 over root 2. So let me actually just draw them in. I'll pause and draw them in because I'm running a long time. So to go from the hypotenuse to the leg, you divide by root 2. So you divide by root 2 and you get 1 over root 2, you get 1 over root 2, and if you rationalize the denominator, which is something from algebra 2, you get root 2 over 2. So what that means is, over and up, you go up root 2 over 2, so that's the y value, and you go over root 2 over 2, that's the x value, except, wait, we went to the left. So it's negative. It's negative root 2 over 2. Okay, so it's negative root 2 over 2. Positive root 2 over 2 are your coordinates. Negative root 2 over 2. Positive root 2 over 2, because we go to the left and up.